Cosine is?
Cosine.
Cosine. So the integration is backwards, it's negative cosine, okay? What was the derivative of cosine always? Negative sign, so the integration of cosine is positive sign. So just remember it's opposite, okay? And you'll never forget it. All right, and there you go. Okay, number 19. Oh, look at this, we have a what? We have an exponential added to something that is something trigonometric? Trigonometric, yes. All right. Now, to take the derivative of an exponential, you copy it down, and then you multiply by the what? Natural log base. To take the integration, you do the opposite. So you, something copy it down, but divide by the natural log base. So it's opposite. Okay. All right. And that's it for that one. Now for the 5 tangent of x. The 5 is a coefficient, therefore it just carries along to the right. That's always true for coefficients. Whose derivative gives you tangent? Don't put secant squared, right?
No,
Okay?
it's negative.
It is the natural log of the absolute value of not secant squared, but just secant inverse.
Why is that again?
Okay? There's a reason for this. This one you just kind of memorize. Very rarely in Mr. Wade's class do you have to memorize it, once you just understand what you're doing. But in this case, you kind of memorize this one. But there's a reason we did the derivative in class, remember? If you do the derivative of this, isn't natural log 1 over, right? And when you do the derivative of this crazy equation right here, you get 1 over cosine times sine, and sine over cosine is tan. That works. Okay? Very correct. All right. Now, that's perfect right there. Done. Okay, so just memorize that one. If you would like to memorize the alternate version, that is okay too. The alternate version is minus 5 natural log of cosine of x. Because secant is cosine to the negative 1, isn't it? It's the reciprocal of cosine, right? If secant is cosine to the negative 1, can I kick the negative 1 out to the front only in natural log rule? So that is the same thing mathematically. Okay? If you prefer this version, that's fine. You can memorize this version. If you like the other version, memorize that version. Okay? Either one. All right? There you go. Something I understand. Okay? Not too bad, right? Just know your antiderivatives. There are like, I think there are 11 derivative rules we've been through this year. Although we don't use the arc sine or the arc tangent very often, so actually there are 9 common rules we use for derivatives. There are only 7 for integration. That's it. Like sine, cosine, tangent, those are 3 right there. So you really don't have that many things you should be able to integrate. So, and we cannot integrate natural log of x until you learn integration by parts in college. Or UC. All right? So, really your pool of knowledge as far as things you should be able to integrate is not very big. Just 7 basic functions and that's all. So I can't really fool you too much on that section right there. It's going to be something like all those. I covered all of them right there. Okay, now number 20 is an average y-coordinate problem. All right, let's go to a graph here, see what we're looking at. Y equals x squared, we know that one, don't we? Sure. Parabola. I'm going to chop it off from 2 to 3. Okay? Block the graph. All right, there's a point, there's a point, and I want the average y-coordinate. You know what? There's a lot of y-coordinates between 2 and 3. Right there. Matter of fact, there are infinite. Okay? Now, as human beings, we can't add up an infinite number of numbers, although integration has the power to do that for you. It actually can add up infinite cases. Otherwise, we couldn't do it. Okay? We can't physically add infinite numbers. So here's what we're going to do. First of all, if we're talking about y-coordinates, you may want to actually get the only 2 y-coordinates that we'll know so far, and that is plugging in 2 and plugging in 3. What is the y-coordinate at x equals 2? That would be, plug it in, x squared, 4, and 3 comma? 9. Okay, so let's start with that. Oh, so if I average all of the infinite little y coordinates, my answer should be between what? 4 and 9. I had a whole bunch of tests this year. My lowest test score was 4, my highest was 9. That's not very good. Okay? Therefore, your test average is probably going to be between 4 and 9 somewhere, right? It can't leap above that, right? Okay, so all my test scores are in here. What's my average? Okay. Now, adding up an infinite number of numbers. If you use integration, it will add up infinite things for you. If the curve is y equals x squared, does anybody know what the formula is for all the y coordinates on this parabola? What is the formula that would give you all the y coordinates in this parabola? Wait a minute. The formula that tells me all the y coordinates on this parabola. Where do we get the 4 and the 9 from? Oh, that's the formula right there. It says y coordinate comes from x coordinate squared. That is the formula for all the y coordinates in general. Right there. Aren't they all just x squared? Right? So you're going to integrate or add up all the infinite y coordinates, but aren't the y coordinates actually known as whatever x squared is? Right? Isn't that y coordinate right there? Okay. So you're going to add up all the infinite y coordinates, and let's put a little dx right here. Okay. All right. So infinite sum y coordinates would be x to the third over 3. You don't need the plus c really for this particular problem. They'll just cancel out, so you can leave that off if you want to. Okay. You can put it in, okay? Now, what we have to do is plug in our endpoints, 2 and 3, and let's see where we are here. At 2, what would you get? Okay? 8/3. At 3, the other endpoint, what would you get? You would get 27/3. We will not change that into 9 because we need a common number. And then, if you recall, you do the same thing we did on an old test for horizontal distance. You do right minus left. X equals 3 is on the right, x equals 2 is on the left. What is 27/3 minus 8/3? 19/3, okay? Now be careful. I think if anybody misses on the test, it's going to be right here. 19/3. What you just did was an infinite sum. I just added up all my test scores and got this big, gigantic number. Well, I guess it's my average. We never divided. That's a total value, okay? You actually luck out in this one with the sample test. Yeah, what's the gap of the space we've lucked out? It's only 1. So technically you were supposed to divide this by 1, but if you forgot, you did the same thing. Now, wink, wink. On the test, it's not going to be a gap of 1. It's going to be something else. So don't forget, don't just tally the total value, get the average value. Okay? By the way, does anybody know what 19 over 3 is? 6 and 1/3. Is 6 and 1/3 between 4 and 9? And that's a logical answer. That's good. Matter of fact, the midpoint of 4 and 9 is 6.5. Do you know why it was lower than just the strict mid value? The line, the linear graph, would always be above the curve if the curve is concave up. Jillian with tons. That was a free point plus thing. Nice job. Well, hey, I'm throwing it out there. Very nice. So it's concave up. The number is lower than the midpoint.
Yeah.
Okay, oh, catchphrase. All right. Test Wednesday, test Thursday. Be prepared. Oh, tutoring today if anybody needs help on that.